Okay, today we will be working on sampling and taking surveys. There's a lot of vocabulary in this lesson, so hopefully you will be able to pick up on some of this vocabulary and look over it tonight and be able to answer questions on the quiz that we're taking. Okay, so first of all, everything in taking a survey has to be random. You can't go out and take a survey and not think about random, because if you don't, then you may cause some kind of bias to come out in your survey. And so we can talk about different ways to randomly pick things. But before we can do that, we have to understand that, am I asking the whole entire population, every person, or am I just asking a small group? So, for example, if we talked about the population of North Stokes being 312 students, if I send out an email to everyone and everyone answers the email, I've done a census of North Stokes because I've asked the entire population. But if I only ask 15 people out of each grade, then I've asked a sample. And then I'm going to try to say that based on what this sample said, I have that North Stokes would be the same answer. So that's the difference between a census and a sample. Census, you ask everybody in the group. Sample, you just ask a small group within a group. So there are 25 students who want to choose 3 of those to bring food to a class party. But there are many ways in which we could choose these 3 students. But we want them each to have an equally likely chance of being chosen. The following strategies will result in a fair decision or not. Will it be random or not? That's what we're trying to answer. So first, students line up alphabetically. Each one in succession flips a coin, and the first 3 students to flip a coin heads brings the food. Now, if you line these stoves up alphabetically, that's not very random. So as you go through, you're going to find that it not being very random, you don't have an equally likely chance. So this is not fair. Well, it's not writing. Let me try again. This is not fair due to the students are lined up in order. So it's basically has a lot to do with the fact that that's not very random. Now, in our second question, each student draws a card from a well-shuffled deck of cards. The teacher shuffles a second deck of cards and spreads them out and draws a card one by one until he matches the cards of the 3 students. This is a fair sample because each student has an equally likely chance. All right, so you've got to make sure that every student could have a chance of being chosen first, and that alphabetical didn't do that, because whoever comes alphabetically first has a much greater chance than who comes last in the alphabet. All right, random number table. With a random number table, you can divide the table up in different ways. This has been divided by putting the numbers in groups of 5s, just so you can kind of have some breaks in the numbers. It would be a real mess to look at if they all ran together. But we wanted to pick numbers that from 0 to 9 is how this random number table is actually put together. And unfortunately, not every time do you want to pick numbers from 0 to 9. Like this situation, a coach wants to select 3 of their basketball players to be at random to be leading the warm-ups before each practice. Coaches assign each player a number from 0, 1 to 15 to make them a 2-digit number. How can the coach use the random number table to fairly choose 3 players? So underneath this, you can write this answer, but I'm going to write it above it so that I have a little room to see the question. So first of all, you'll start by selecting 2-digit numbers, ignoring 0, 0, because that is a possibility for a 2-digit number, and 16 through 99, because we only want 2-digit numbers from 1 to 15. Alright, so that's how we're going to select them. So we're going to take a 2-digit number. 87 is not. 49 is not. 43 is not. 97 is not. 07 is. So I need 2 more of these, so I keep going. How about you stop the video and you keep going and see what will the next 2 numbers be. Welcome back. Let's see if you're right. 20, 52, 59, 57, 04 will be the next one. 48, 36, 12 will be the next one. So we have 07, 04, and 012 are selected to be the warm-up leaders for the practice. So that's how a random number table works. Simulation. Simulation is when you can't physically do what is being asked of you because of the sheer amount of time it might take or the danger of what it might take into consideration. So you simulate it. And probability is the outcome that what happens during your simulation. So you suppose you are playing a board game and you have to roll a 6 to be able to get out and move around the board. Describe a simulation that you can use to predict the number of times that you expect to have to roll the number cube before you can move on. I can't physically sit here and roll these numbers. That's just not really feasible. I could do some other things that would kind of help this move along. For example, I could use a random number generator. A random number generator basically makes one of these tables like we had on the previous screen. Let's go back. So when you look at this random number table, if I'm running numbers that are only 1 to 6, then I have to exclude 0. I have to ignore 7 through 9. So the first one I'll get would be a 4. The next one will be a 4, then a 3, then a 0, then a 2. Well, wait a minute, 0 is not one of them. 2, and then a 5, then a 5, then a 5, then a 4, then a 4, then a 3, then a 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I had to roll 11 times before I got a 6 using a random number table. That would depend on where I start on the table. It could take forever. Or if I started on the second row, I'd have got it in 4 rolls. If I'd have started on the third row or the 4th row, I'd have got it in the first roll. It's just really random how the random number table just, might take a long time, might not take a little time. You also could use a computer app that rolls a die, because there are apps out there that do the calculations for you. Well, let's just think about it for a minute. The probability of getting a 6 is 1 out of 6. What do you think the least amount of times you'd have to do would be if it's 1 out of 6? Well, I would think it would take 6 tries, because you have 6 possibilities. So it might take 6 tries because you might get 1 of each. And that would probably be the least number of tries it could take. Then again, you might get it the first time. So you just don't know how quickly you're going to get it. I have played a game with my children before with trouble, and I just could not get out of the starting holes because I never rolled the right thing to get out. So let's go over some vocabulary. So sampling methods. Convenience method is basically you just go and do it the easiest way it could be. For example, you need to do a survey and you forgot to do your homework last night. You were supposed to call people and ask these questions and you didn't. So you just ask people on the bus. That's convenience. Voluntary response sample. That means that you just ask for volunteers to answer your question. Systematic. Well, systematic's about doing it on a regular interval, meaning like I do it every third person, I do it every 100th person, I do it every 5th person, I do it every 10th person, that type of thing. Random sample means everybody has an equally likely chance of being chosen, like the card problem. Stratified, picking a common characteristic. For example, maybe I group everyone at North Stokes by what grade they're in, and then I ask the question to a few out of each grade. Or maybe I group them by what math they took this year, and I ask a few out of each math class the question. Clustering sample means you divide it up by a demographic area, meaning basically something about geography. Usually is used, like area code divides up our state into many different areas. But now that we're starting to have area codes that are the same area, that's going to mess up our cluster sampling. Because you won't be able to say you have a true geographic area. But, you know, a city, a zip code, a state, because we know a lot of people, you know, might get called if they're in a specific state during election time to answer surveys. Types of studies. There are 3 types of studies. The first one is observational, where you just go and you observe or you measure something, but you didn't do anything to make that measurement change or anything. You just go measure it. Like maybe you go capture a bunch of deer and you count how many antler points they have. Or you just observe the deer out there and say, whoop, there goes a white deer. Controlled experiment. You have 2 groups usually in a controlled experiment. First, there's the one that's being treated because they're getting the medicine. And then you have your control group that's getting no medicine, but you want them to think they're getting it so you can see if that affects the results. And then last, there's a survey. You just go out and ask people a question. Now, when you do this, it could have bias. Bias could be entering into your problem because maybe your sampling method is not the best for the problem you're having. For example, if I just go ask a bunch of students at North Stokes the question, I might get all seniors. Or if I'm having people call in on the radio to volunteer to answer a question, you know, if I'm listening to a really young person's radio music, then I might not get anybody in every demographic age group. Now, it's important that your control group either receive nothing or receive a placebo. For example, people would have to receive a placebo because we want to think we're getting it. But if I'm giving the vaccine to some animal, then I don't have to worry about it thinking it needs a placebo because it's not going to know the difference if it got it or not. Double-blind experiment means that the people who are in the study and the people who are doing the study don't know who got the medicine, which is important because I might record that somebody got better who didn't even receive the medicine. And sometimes if that could cause what we call a lurking variable. A lurking variable is that somebody didn't get the medicine, they got better. If a bunch of people did that, then I would wonder, why are they getting better? Because they shouldn't have gotten better. They didn't have the medicine. So what type of sampling method is the next scenarios, and is there any bias? A service survey every 25th in the local directory. So if I'm asking every 25th person, then that is systematic. The reporter interviews people on the street in a large city. Well, you know, if you're going around and you are reporting who these people are, you know, might vary. For one thing, it depends on what street you're on. If you're in a poor neighborhood versus a wealthy neighborhood versus a business district versus what time of the day might cause bias, because different kinds of people might be out at different kinds of day. You get out there in the middle of the morning and you might have all the moms. You get out there at 5 o'clock, you've got the working man. So it's a big difference. And then the radio station allows people to call in and give their answers to the survey, would be volunteering. So in this first one, with I forgot to talk about the bias with that one. And then, so this was systematic. And the bias is a directory has a list of people. Everybody might not be in the directory, like a phone book directory. Everybody doesn't have a landline anymore. Again, I talked about the reporter having bias because you might have different kinds of people coming by depending on where you are, or different kinds of people come because of the time of day. The radio, the bias again is that you don't know you're getting a good demographic of all the different age groups, because you might be listening to hip-hop, and an old person wouldn't be listening to hip-hop, so you wouldn't get enough old people answering your question. All right, to create an unbiased question, you have to avoid the common things that are listed here. Combining two or more issues, using double negatives, like saying, I will not ever, never ever get married. Overlapping an answer choice, maybe making two of them seem kind of similar. Words that cause a strong reaction, like if I start to say something to you and I say, well, please answer this question about gun control. You've already made up your mind if you're against or for it, and you haven't even heard the question yet. And leading the subject to the answer. All right, so we're going to talk about bias in each of these, and we're going to talk about which one of these bias things at the top does it break if it has bias. Do you think that food and beverages are served in the cafeteria taste good? Now, I'm not answering that question. I'm asking, if I ask this question, is there any bias? And yes, there is, because food and beverages are two different topics. So you need to only ask about food or only ask about beverages. In fact, you might even want to get more specific and ask about a specific food. Do you agree that school days should be shorter? This don't you agree part here is leading you to try to get the answer I want. I'm leading you to it, and that causes bias. Do you prefer watching exciting movies or dull books? So reading, because they used the word dull, might turn you off. Exciting might make you want to watch the movies. Of course, if I said, would you like to watch silent movies versus action films, that also might turn you off, because the word silent means you're going to have to read. So, certain words in the question can turn the person off on what their answer might be. All right, in this next question, we're choosing between sampling, experiment, simulation, and census. Remember, the difference between sampling and census is sampling, you take a small group. Census, you have the entire group. Experiment, you did something to see what the result would be. And simulation, it's something you can't do physically due to the amount of time it would take, or it might harm somebody. An analysis of a sample of 31,000 patients in New York hospitals suggested that a poor and elderly sued malpractice at 1/5 the rate of wealthy patients. And they told you it was a sample. So I think that's sampling. The effects of wind shear on planes, both landing and taking off, is studied by a complex computer program that mimics the actual flight. Well, I hope we don't go out there and land planes if we're not sure they're going to land properly. So that's why that is a simulation. Studying football scores obtained through touchdowns and field goals was conducted by the National Football League, determined whether the field goals accounted for most scoring events than touchdowns. And this is a census, because they went to the Football League and got all the scores to do this with. And then an Australian study of 588 men and women had some precancerous skin lesions. Half of them got a cream, half of them got a placebo cream. And after 7 months, we went back to see how many more cancers they had, and the one that had the medicine had fewer. That is definitely an experiment, because we didn't give both groups the same thing. We gave one the medicine and one the placebo to see if that would have any effect. All right. And then on this one, we're picking between cluster, which means demographics like a geographical area, convenience. We just walked up and asked somebody that was easy to find. Random, we're randomly picking people. Stratified, we're doing it based on a group have been designed, and then we are picking some out of each group. And systematic, we're picking the nth person. So the number of units in that area, use a random number table to select apartments to include us in the sample. Well, obviously that's simple random because you're using a random number table. Classify the apartment units according to the number of bedrooms, and then take a random sample from each class. So that means I've got a group of 1 bedrooms, 2 bedrooms, 3 bedrooms. I'm taking some out of each group. That is stratified because I first put them into groups. Classify the apartment according to the zip code, and then randomly choose people from the zip code. So therefore, that is clustering, because zip codes are done by geographics. And then looking in the newspaper and choosing the first apartment you find in the list, that would be convenience, because you're not really working really hard at it, you're just picking the first one. And then E, every 5th apartment is put into the sample is systematic. So our last question here is, how would you use a randomizing 2 treatment experiment in each of the following settings? Is a placebo being used or not? A vet wants to test a strain of antibiotics on calves to determine their resistance to a common infection. In a pasture, there are 22 newborn calves. There's enough vaccine for 10. However, blood tests will be done to determine the infection, can be done to determine the resistance to the infection. So I have 10 calves getting the drug. And I have 12 calves. Now, it would have been nice if that had been even, but I have 12 calves with no drug. They didn't even get a placebo. Well, not like they need one. I mean, cows don't know that they're not getting, and they don't get better just because they thought they got something. So there's our random 2 treatment. And is a placebo being used? No, it's not being used because we don't have the other group getting any medicine. Part B, the Denver Police Department wants to improve its image with teenagers. A uniformed officer is sent to the school 1 day a week for 10 days. Each day the officer visits with students, each lunch, attends pep rallies, and so on. The 18 schools were then sent a survey, but they could only go to half of these schools. But everybody got surveyed. So you got 9 schools with an officer, and you've got 9 schools without. And we're meant to survey all of them. So that's a 2 treatment. Unfortunately, I think when you do something like this, you really should look at all the 9 schools that did get the officer and know that their data is together, because you're going to want to see, did that effect really help? And then the schools that didn't have the officer, well, that depends on if they know the others had it. If they know the others had it, that caused bias. As long as they don't know the other schools had an officer, then their opinion of the officer is not going to be any different than it would have been if nobody had seen an officer in the schools. So that's important not to cause that bias. And then the last one, you've got 75 cigarette smokers volunteered for this new skin patch to try to quit smoking. 40 of them took it. So one group is 40 volunteers got the new drug. The other group is 35 that are left got the no drug patch. So that's the placebo to make them think that they got it. And with this particular situation, there are occasions where if somebody thinks they got it, then they might quit smoking and not realize that they quit on their own, that they had the willpower all along. I'll give you an example of that on the Andy Griffith Show. There was this little old lady who always got her pills at the drugstore. Well, a new lady druggist came in and asked, and she put her dime down on the counter and says, "I want my pills." And so then the lady druggist says, "Well, do you have a prescription?" And she says, "I don't need a prescription. I do need my pills." And she said, "Well, I'm sorry, I can't give them to you because you don't have a prescription." She says, "Oh no, I'm going to be on my deathbed in no time." So she goes home and lays down on the couch and doesn't get up for days, and everybody in the town's concerned, bringing her food, trying to help her, fussing at the lady druggist. So the lady druggist calls her uncle, who used to own the store, and said, well, what in the world am I supposed to do? She's on her deathbed, and I can't give her the pills because no doctor has prescribed them. He says, I didn't give her any real pills. I just gave her sugar pills. She thinks they help her. And so therefore, because she thought they helped her, that she thought she needed them. And so the lady druggist puts some of those sugar pills in a bottle and puts a label on it, takes them to her, and says, well, I found out what pills you need. I called my uncle, and he told me. So here are your pills. Now let me go get you a glass of water, and I'm going to give you these pills. She says, oh, bless you, darling. I'm just about at my desk door. While she's sitting there eating a big, huge chicken leg. And so the lady druggist brings them over there and gives her the pill and the water, and immediately she jumps up and she's just fine because it's all in her head that she needs these pills. And that's kind of the same thing that happens sometimes with these drug trials. Somebody who's in the control group that gets the placebo might get better just because they thought they could get better. And that's what they tell people who have cancer now, that your attitude to your treatment is everything. That if you think you're not going to get better, you're not. Because your attitude about being positive can help your treatment to work better, because mind over body is a really important concept in the scheme of things. And I'm not going to say you're going to will yourself to be better, but I'm going to say that, you've got to realize that that positive attitude could help you to get the medicine to do what it needs to do. So they found in drug trials sometimes that the people who had the positive attitude with no drugs got better. All right, I think that's the last slide. Yes, so now you'll be able to do the work on 8.6.